Hello, my name is Lorenzo Legaspi, and I will be presenting my arc length project for my AP Calculus AB class. So the path I chose is located in my neighborhood, Hasbrouck Heights, New Jersey, and the reason I chose this path is to determine my lap to mile ratio. Usually I use this path to run, and it would be nice to know approximately how much I run every day, how much I run when using the path. So the path includes 6 straight lines, one on Cleveland Avenue, one along the trail, one along Roosevelt Avenue, one along Harrison Avenue, and one along the boulevard. There are also 2 curves, which are both parabolas, the bigger curve being a combination of the Woodland Park Trail and Roosevelt Avenue, and the smaller curve being comprised of Harrison Avenue. So first I will be looking at the bigger curve, which is the combination of the Roosevelt Avenue and the Woodland Park Trail. So I was able to find these points using Google Maps and the measurement tool I was given. So the points I used were 0, 0, negative 9650, negative 6224, 6020, and 9041. So I decided to make the origin be on the vertex of the curve, just to make everything seem centered around that point and just to make it seem a lot more organized. So using Desmos, I was able to find the curve by using regression. Desmos had a very easy to follow tutorial as well as a very easy to use program. I was able to enter values in a table, and then using regression I was able to find this graph. And with that graph I was able to find an equation, with it being f of x equals 0.00513751 x squared minus 0.0190212x plus 1.52861. And to be able to use the arc length formula, you must find the derivative of this equation, which it being f prime of x, which is equal to 0.010275002x minus 0.0190212. And when plugging this into the arc length formula, I found the curve to be 211.48774 feet approximately. And this is after using the limits of integration being negative 96 and 90. Next, we move on to the second curve, which is the curve which is made by Harrison Avenue in the map. So once again, I was able to use the measurement tool that was given to me in the Google Maps to find all my points, and these points being 0, 0, negative 40, 17, negative 57, 36, 50, 15, and 65, 35. And using these points, I was able to create an equation and a graph using, once again, Desmos and regression. After plugging in my values into a table and plugging it into this formula, I was able to find, once again, another graph, similar to the one before, as they are both parabolas. And once again, I found another equation, with it being f of x equals 0.00977411x squared minus 0.0991282x minus 1.66824. And the derivative being 0.0195482x minus 0.0991282. And once again, plugging in to the arc length formula to find the length of the curve, with the limits of integration being negative 57 to 50, I was approximately able to find the length of the curve, with it being 125.17593 feet. And then we look at the 6 side lengths, which I was able to find using the measurement tool, once again given to me by Google Maps. And finding these 6 lines were no trouble due to them once again being straight lines, and no calculations were needed, only the graphing tool was needed. With line 1 here along Cleveland Avenue being 325 feet, line 2 here along Harrison Avenue being 214 feet, line 3 along Harrison Avenue once again being 1,385 feet, line 4 along the boulevard being 272 feet, line 5 along Roosevelt Avenue being 1,815 feet, and last of all, line 6 along the Woodland Park Trail being 306 feet. And finally, I added up all these distances in order to find the total distance of the path. I added up the 6 lines and the 2 curves in order to find this total distance. In the end, that total distance ended up being 4,653 feet, or approximately 0.881 miles. The Google Maps distance ended up being 0.899 miles, which is just a little bit above the total distance that I calculated. And of course, there is no perfect value due to the distance all being approximated and done by hand. And in conclusion, the average lap to mile ratio is just under 0.9 miles per lap. It is nice to know this value when I'm going out on a run, or in general in using this path when maybe walking someone's dog, or just using it to hang out with friends. It is nice to know how much I walk or run when using this path. Thank you for listening to my presentation. My name is Lorenzo Legaspi, and this was my presentation on my arc length project.